The Milky Way, a sprawling island of stars, stretches across the cosmic canvas in radiant brilliance. Its spiral arms unfurl like glowing ribbons, woven with countless suns, nebulae, and interstellar clouds. Each star is a beacon, a testament to the vastness and complexity of our galaxy, a tapestry woven over billions of years, humming with the silent energy of creation and destruction. Yet, among these shining jewels, there are realms where light falters and shadows reign. These are the voids, the mysterious abysses where the ordinary laws of physics bend, twist, and sometimes break. As we journey deeper into the heart of the Milky Way, the gentle glow of starlight begins to thin. The familiar constellations dissolve into a backdrop of velvet blackness. Here, in this somber expanse, lies one of the most enigmatic phenomena in the universe, the black hole. To the human eye, it appears as a pit of utter darkness, a region where not even the faintest photon can escape. But around its edge, the story is dramatically different. The gravitational pull of a supermassive black hole is so intense that it warps the very fabric of space and time, bending the paths of light and distorting everything that lies in its vicinity. At its center, a gaping maw, the event horizon, marks the boundary between the known and the unknowable. Anything crossing this threshold vanishes from view, lost to the singularity that lurks within. Yet, swirling around this invisible frontier is a spectacle of cosmic violence, the accretion disk. Vast streams of gas and dust, drawn inexorably inward by the black hole's gravity, spin in a fiery dance, heating up as they spiral closer to oblivion. The disk glows with fierce, radiant colors, from deep reds and oranges to brilliant whites and blues, a blazing testament to energies beyond imagination. Light, too, behaves strangely in this domain. As it passes near the black hole, its path curves, contorted by gravity's relentless grip. This phenomenon, known as gravitational lensing, creates surreal effects. Stars and galaxies behind the black hole appear stretched, magnified, or even duplicated, their images smeared across the cosmos like paint on a canvas. The very nature of reality is distorted, revealing a universe where the familiar rules of perspective and distance cease to apply. But how does such a monster come to be? The birth of a black hole is a tale of both wonder and tragedy. It begins with a massive star, many times more colossal than our sun. For millions of years, nuclear fusion rages at its core, forging heavier and heavier elements and supporting the star against the weight of its own gravity. Eventually, the fuel runs out. The outward pressure disappears, and gravity wins the battle. In a final, cataclysmic collapse, the star implodes, its core crushed into a point of infinite density, a singularity. The outer layers are blasted away in a supernova explosion, briefly outshining entire galaxies. What remains is a newborn black hole, silent and invisible, a remnant of a life once burning with fierce brilliance. To grasp the sheer scale of transformation, imagine our own sun, a modest star, warm and sustaining, the anchor of the solar system. If, by some impossible magic, it were to collapse into a black hole, its mass would remain unchanged, but its size would shrink to a sphere barely a few kilometers across. Yet, the planets would continue their orbits, undisturbed, as if nothing had happened. The sun's gravity, though now concentrated into a tiny point, would exert the same force. This dramatic comparison underscores a profound truth. Black holes, despite their fearsome reputation, are simply the ultimate expression of gravity, an inevitable fate for the most massive stars. At the very center of our galaxy lies the most famous black hole of all, Sagittarius A. Hidden behind veils of dust and gas, it anchors the Milky Way, its mass equivalent to 4 million suns. For decades, it remained a shadowy mystery, inferred only by the furious motion of nearby stars, whipped around at speeds that defy comprehension. Today, thanks to cutting-edge telescopes and global collaborations, we have begun to peer into this cosmic abyss, capturing the faint glow of its accretion disk and the subtle warping of light in its gravitational well. Sagittarius A is a silent sentinel, governing the dance of stars and gas at the galaxy's core. Around it, young stars cluster in tight swarms, their orbits tracing invisible lines through the darkness. Occasionally, a star ventures too close, torn apart by tidal forces and devoured in a burst of energy. The process is violent, yet elegant, a reminder of the delicate balance between creation and destruction that defines our universe. But beyond the dramatic scenes and awe-inspiring visuals, black holes challenge our very understanding of reality. They represent the limits of our knowledge, where the laws of physics break down and new theories are forged. Inside their event horizons, space and time fold into themselves, and all information is lost. Scientists grapple with paradoxes and mysteries, from the nature of singularities to the fate of matter and energy that vanish within. Yet, amid this darkness, black holes are also engines of cosmic evolution. Their gravity shapes galaxies, stirs up interstellar clouds, and triggers the formation of new stars. Their collisions send ripples through space-time, gravitational waves that we can now detect and study. Each black hole is not just a destroyer, but a creator, a force that sculpts the universe on the grandest scales. Our journey to the heart of darkness is far from over. With every new observation, every burst of high-energy radiation, and every subtle distortion of light, we learn more about these enigmatic objects and the fundamental workings of the cosmos. In the swirling chaos of accretion disks, the bending of starlight, and the silent collapse of massive stars, we glimpse the profound interconnectedness of all things. A universe where light and shadow, matter and energy, birth and death are forever entwined. As we gaze upon the epic grandeur of Sagittarius A, we are reminded that the quest to understand black holes is not just about deciphering the secrets of the universe. It is also a journey into the unknown, a testament to human curiosity, imagination, and the relentless drive to explore. In the heart of the Milky Way, where darkness reigns and light is bent to its will, we find both the ultimate challenge and the deepest inspiration, an invitation to venture ever further, seeking answers in the silent, timeless depths of space. The universe is a stage for forces beyond imagination, and at its heart lie some of the most powerful and mysterious objects known to science: black holes. These cosmic titans are born from the death throes of massive stars, collapsing under their own gravity to form regions of space where the pull is so strong, nothing, not even light, can escape. But the true power of black holes is revealed in the dramatic events that unfold around them as they warp, twist, and reshape the very fabric of the universe. Imagine a star wandering too close to a supermassive black hole. The star's journey is calm at first, but as it approaches the black hole's immense gravity, the serene pace escalates into a violent ballet. The star is stretched and squeezed by tidal forces, an effect so powerful it shreds the star apart. This is known as a tidal disruption event. The star's outer layers are torn away, spiraling around the black hole in a luminous disk of gas. For a brief moment, the doomed star blazes brighter than it ever has before, its light outshining entire galaxies as it is devoured piece by piece. But the spectacle does not stop there. The black hole's gravity is so intense that it warps the path of light itself. As the remnants of the star swirl in, beams of light passing near the black hole bend along curved, warped paths. In slow motion, one can imagine these rays of light looping, spiraling, some slipping past the event horizon, never to escape. The closer the light travels to the event horizon, the ultimate boundary, the sharper its path curves until it seems to swirl around the black hole in a mesmerizing dance, painting glowing rings and arcs across the darkness. This warping of space and time has even stranger consequences. Near the event horizon, time itself begins to slow. To a distant observer, a clock falling towards the black hole ticks ever more slowly, as if the universe itself is freezing the passage of time. What feels like seconds to the falling object might be centuries to an outside watcher. This phenomenon, known as time dilation, is one of the most mind-bending predictions of Einstein's theory of relativity. The closer you get to the event horizon, the slower time moves until, at the very edge, time seems to stop altogether. Yet, even as material falls in, black holes reveal another extraordinary power. From their poles, jets of plasma and energy erupt, shooting out into space at nearly the speed of light. These jets are born from the furious dance of magnetic fields and charged particles in the accretion disk, where matter is heated to millions of degrees before plunging in. The energy unleashed in these jets can span thousands of light years, piercing through the darkness of space, lighting up galaxies, and shaping the cosmic environment around them. But perhaps the most awe-inspiring display of all occurs when two black holes meet. Drawn together by gravity, they spiral closer and closer in an ever-quickening embrace. Their massive forms warp the fabric of space itself, sending out ripples known as gravitational waves. As the black holes collide and merge into a single, even more massive entity, these waves wash across the universe, distorting the space between galaxies and reaching detectors here on Earth as faint, fleeting whispers from the depths of space and time. To witness these events is to glimpse the raw power of nature. Imagine drawing closer to a black hole's event horizon, the boundary between the known and the unknowable. As you approach, the world around you shifts and distorts. Light from distant stars bends and wraps around the black hole, forming glowing halos of energy. The pull of gravity grows ever stronger, and time itself slows to a crawl. The edge of the event horizon looms before you, a shimmering veil beyond which lies complete darkness. At this boundary, all the forces we know, gravity, light, time, are pushed to their absolute limits. Beyond the event horizon, nothing returns. Not matter, not information, not even the light that once illuminated the universe. It is here that our understanding fades and the true mystery of black holes begins. And then, as the last rays of light curve inward and vanish, all that remains is darkness. The universe, for a moment, is utterly silent and still, save for the faintest echo of gravitational waves traveling across the cosmic sea. In this darkness, the immense power of black holes lies hidden, waiting for the next star, the next collision, the next event to unleash their unimaginable might once again. The story of black holes is a story of extremes: the stretching and tearing of stars, the bending of space and time, the eruption of energy and light, and the collision of cosmic giants. These events remind us that the universe is far more powerful and mysterious than we can ever truly comprehend. In the presence of a black hole, even the most fundamental laws of reality are challenged, and we are left to marvel at the incredible forces at play in the vast, dark heart of the cosmos. Inside the heart of a black hole, reality bends in unimaginable ways. Here, the known laws of physics begin to unravel, and the fabric of space and time stretches to its limits. Imagine, for a moment, plunging past the event horizon, the point of no return. Around you, the darkness isn't empty. It's alive with the roar of distorted light and the warping of time. In this abyss, a tunnel begins to form, swirling with energy and possibility, the mouth of a hypothetical wormhole. This tunnel, like a bridge, carves a path through the very structure of the universe, connecting distant realms that would otherwise remain forever isolated. As you move deeper, the tunnel pulses with strange swirling currents. Around its edges, space twists and folds, forming a corridor that defies everything we know about distance and direction. For a fleeting instant, you glimpse other universes, alternate realities with their own stars, galaxies, and histories. Through the wormhole's shimmering walls, you see galaxies spiraling in unfamiliar patterns, worlds where the laws of nature might be subtly or radically different. Each possibility flickers past, like scenes glimpsed through the windows of a speeding train, hinting at the vastness of the multiverse beyond our own cosmic island. At the edge of the black hole, a faint, ghostly glow radiates outward. This is Hawking radiation, theoretical, elusive, and hauntingly beautiful. It's the slow whisper of the black hole's demise, a process that takes place over time, spans so long they defy comprehension. In the cold darkness of space, this glow is a pale signature, a final farewell as the black hole gradually evaporates, shedding mass and energy back into the cosmos. It's a reminder that even the mightiest cosmic giants are not eternal. They, too, are part of the universe's grand cycle of birth and transformation. But black holes are not merely cosmic destroyers. In the grand tapestry of the universe, they play a creative role as well. Their immense gravity sculpts the galaxies themselves. Around the supermassive black holes at the centers of galaxies, clouds of gas and dust swirl in vast luminous disks. These structures help shape the spiral arms that define the graceful forms of galaxies, like our own Milky Way. The gravitational influence of black holes acts as a cosmic anchor, helping to organize the orbits of billions of stars and the swirling rivers of interstellar matter. In this way, black holes are both sculptors and sentinels, molding galaxies from chaos and holding them together through the eons. Pulling back, the scene widens. The black hole, once a singular point of mystery and power, is now just one among millions of stars. The galaxy stretches out, a luminous whirlpool of starlight, dust, and dark matter. Each pinpoint of light is a sun, possibly with its own family of planets and moons. From this vantage, the black hole's influence is subtle but profound, its gravity helping to choreograph the cosmic dance unfolding on a grand scale. As the view expands still further, the Milky Way comes into focus in all its majestic splendor. Its spiral arms shine with the collective light of hundreds of billions of stars, woven with rivers of gas and dust, dotted with the glowing birthplaces of new stars and the remnants of ancient ones. The central bulge glows brighter, marking the home of a supermassive black hole, a region where gravity reigns supreme. From the outer reaches of the galaxy, the spiral pattern is unmistakable, a cosmic fingerprint written across the vastness of space. Yet even the Milky Way is but a single note in a cosmic symphony. The camera of imagination continues to pull away, revealing the true scale of the universe. All around, the darkness is punctuated by the light of countless galaxies, each one a swirling island of stars, gas, and dark matter. Some are grand spirals, others elliptical or irregular, each shaped in part by the black holes at their hearts. Together, they form a vast web stretching across the cosmos, bound together by gravity and the unseen forces that shape our universe. In this ultimate zoom out, the universe reveals its full grandeur, a tapestry woven from billions of galaxies, each with its own story. The distances between them are unfathomable, the numbers so vast they challenge the limits of human imagination. And yet, from the smallest particles to the largest structures, everything is connected. Black holes, once thought to be mere voids, turn out to be vital threads in this cosmic fabric. As the scene fades into the deep silence of the cosmos, we're left with a sense of wonder. Black holes are not just the endpoints of massive stars or insatiable cosmic vacuum cleaners. They are gateways to understanding the fundamental laws of nature, laboratories for the extremes of physics, and perhaps even portals to other universes. Their presence shapes galaxies, drives the evolution of stars, and challenges us to rethink what we know about space, time, and reality itself. The story of black holes is, in many ways, the story of the universe itself, a tale of creation and destruction, of chaos and order, of mystery and discovery. From the singularity at their heart, where the rules of physics break down, to the faint glow of Hawking radiation at their edge, black holes span the extremes. They connect the smallest scales of quantum mechanics to the largest structures in the cosmos. They force us to confront the unknown, to question our assumptions, and to push the boundaries of science and imagination. The journey beyond the black hole is a journey into the heart of the universe. It's an invitation to explore not just the cosmos, but our own capacity for wonder and curiosity. In the cosmic silence, as galaxies drift through the void, the story continues. Written in the language of stars, shaped by the invisible pull of gravity, and illuminated by the faint glow of possibility. The universe is vast, mysterious, and ever-changing, and black holes are among its most enigmatic and awe-inspiring creations. As we look outward, we are reminded that the unknown is not something to fear, but something to embrace, a frontier that calls us forward, toward discovery, understanding, and the endless adventure of the cosmos.